All right, hello everyone. All right, just letting the last couple of people trickle in here. Thank you so much for coming to our talk. My name is Megan O'Keefe.
Steve Louie.
And this is Are You Ready to Be Edgy? Bringing your applications to the edge of the network. This talk is going to be all about edge computing and approaching edge as a multi-cluster Kubernetes problem, which is exciting stuff. Just to give a little bit of background, both of us are engineers at Cisco. We work near Boston on a rapid prototyping team. We work on all sorts of different projects, ranging from data center stuff, cloud stuff, video stuff. The last year for us has been mostly focused on edge computing, so that's what we're here to talk all about. So in this talk, we're going to try to give a whirlwind tour of edge. First, I'm going to cover sort of what is edge computing, why does it exist, talk about some cool use cases, and then talk about what makes an app ready to be deployed at the edge, some architecture considerations, and then Steve is going to dive into some platform architecture for edge and give a demo of multi-cluster edge Kubernetes. So let's dive right in. I'd like to first sort of take a step back and think about all of the devices that are connected to the internet today, right? You're holding one, you might drive one, might wear one, and we kind of take this for granted, but when we think about all of the traffic that these devices produce and consume, they're talking to the cloud in the vast majority of cases. And when these devices talk to the cloud, right, and produce all of this data, it can put sort of a bottleneck on the network. And so we have kind of a bandwidth problem. And also just thinking about latency, again, some of these emerging use cases, think about things like connected cars, virtual reality, smart home devices, just a whole bunch of use cases that are requiring ultra low latency. And we're not talking just like regular low latency, we're talking like single millisecond kind of latency, right? Where in some cases, talking from device to cloud is actually not sufficient anymore. It's not possible to get that kind of latency. And so what we've basically spent the last year thinking about is how could we address this from a compute perspective? We think of the cloud as this sort of ubiquitous thing, but in some cases we have to start thinking about actually physically moving the cloud. You have the device and you have the cloud, and you have to move one of them, right? And so how could we move the cloud closer to the device? So at a high level, that's why edge computing exists. This is a really hard problem. There's a whole bunch of people trying to think about it and address it. And so, one way to address this is with edge computing. And so this is a very generic definition for what edge is, sort of by design. Edge computing is a very vast space, and you hear a lot of kind of competing terms and definitions. We're happy to kind of field any questions about that, because we know it's right now kind of like a confusing and very new space. But really what edge computing is it's exactly this. It's the process of moving applications from the centralized cloud out towards the edge of the network. And so just to kind of clear the air, right, edge is not a replacement for the cloud. And so you hear sometimes the phrase cloudlet, all these little clouds, these like tiny little data centers all over the place, right, serving requests. Edge is not necessarily a replacement for the cloud. We see edge as the evolution of cloud. Thinking, 5 years from now, 10 years from now, we think of kind of this utopian vision, right, where the cloud is the edge, right? The cloud just has a much deeper footprint down into the edge of the network. And so, given that edge has a lot of different shapes, we kind of have a couple diagrams here on the left. Some of your phones may already be serving edge workloads. Some phones now have dedicated chips that do specific things, like different machine learning tasks. That's edge, right? That's moving a workload out of the cloud. But for us, mostly what we deal with is thinking about edge compute not as cloud, not as end device, but somewhere in the middle. Thinking about something like an edge microdata that can serve applications and talk to the cloud and also talk to the device. So on the right here, we show an example of a car. Picture a vehicle moving down the highway. It needs to access some sort of back-end application. And ideally, that car is always accessing the closest instance of that application, which could dynamically change, right, really, really fast as that car moves down a highway. And so to kind of dive into a couple of use cases before we get into the juicy Kubernetes stuff, Generally, when we think about edge use cases and applications that are actually fit for the edge, that really belong at the edge, we think about these three categories, usually. Applications with very low latency, so VR, AR, lots of IoT use cases. Again, to go back to kind of like an autonomous car situation, think about all of the decisions that car has to make. Do I stop? Do I turn? You need ultra low latency for that. High bandwidth, so video processing is one example, devices that generate a lot of data. And also kind of an interesting sort of thing to think about with edge is this whole idea of ephemeral or temporary data. When you start thinking about applications that span both cloud and edge, enterprises could run an application in both the cloud and at the edge and start being able to promise their users, we're not going to ship your data up into the cloud. We're going to process it ephemerally in one of these edge microdatacenters, and it will never end up in the cloud. So that's been on our minds, lately, thinking about secure data, those sorts of things. So this is a very big slide with a lot of different use cases, and we're not going to touch on all of them. We would love to, and to field any questions that you have. But the whole idea here is that across IoT, across enterprise use cases, across service provider use cases, edge is relevant. There is just a vast array of use cases, and we think of new ones and find new ones floating around every single day, honestly. And so it's a really exciting time in this space. And so I'm just going to touch on two of these use cases just to kind of get a lay of the land before we dive into examples of actually deploying these kinds of applications. The first is machine learning. So this is like the machine learning room. There have been some amazing talks this week about all sorts of different ways of using Kubernetes for machine learning. Kubeflow is one example, right? Kubeflow is comprised of different containers. You have the model train, model serve. So edge could be really cool because say you're an enterprise and you have a machine learning application. Right now, all of it runs in the cloud, which means that serving requests, like serving your model, that happens in the cloud. But ideally, right, you want really low latency for that serving. But the problem is that when you're training your model, you need lots of compute resources. You might need GPUs. You might need even TPUs. Generally, edge microdatacenters are not that high powered, right? You have that sort of advantage of proximity to the end user, but you might not have the advantage of a ton of resources. So what would be really cool is if you deconstructed that application so that your training happens in the cloud, but your serving happens at the edge. So that's just one. We include another use case here with healthcare as one example, I guess, of sort of an IoT example where I think that sometimes, we work with service providers and less with enterprises, but I think it's really important to state that with edge, it's not just, okay, let's put compute at a cellular base station. It's not just let's put compute in a central office for an SP. Whether it's a higher ed institution, a hospital, edge could be relevant for them. You could put compute in a hospital. So in this example, you put something like a Kubernetes cluster on a hospital's private network, and you can serve workloads from there. That microdata center talks to the cloud, and just thinking about things, like managing highly sensitive data. Medical data is very highly regulated, and so just thinking about how they could store that in-house, those sorts of things. Again, just one example. And so I guess what I'm trying to reinforce here is that there are so many different edge use cases. But I guess before Steve dives into some of the Kubernetes stuff, just think about what are maybe some unifying themes across different edge use cases. As this field develops, what does an edge application look like? We have some experience deploying different sorts of workloads on different edge platforms. What are some best practices, I suppose? So the first would be architecture. And I guess before I get into these, a lot of these principles it's really just, a cloud-native application to the extreme. So for instance, if we go back to this machine learning example, right, you are deconstructing your Kubernetes deployment to run literally in different clusters. Going back to, this whole idea of hybrid cloud. Edge is hybrid cloud, right? If something is running in one cloud and in another cloud, it just happens to be a much smaller cloud. But you need these different clusters to all be able to talk to each other. In order to do that, right, you need a deconstructed application, small image sizes, flexibility. You need scalability, right? Your compute and your storage has to all scale together. Edge microdatacenters sort of pose an interesting issue where sometimes, there may not, you might not be able to always guarantee a cloud uplink. So think about, failure resiliency and those sorts of things. Storage. So the whole point of Edge, right, is that you're reducing backhaul. You're reducing the amount of stuff you're transporting up into the cloud. So being able to cache state, only syncing with the cloud when you have to. Steve is going to dive into sort of an example of how we're doing DNS at the edge, so that you're really getting the traffic to route to the closest cluster. And so think about, Kubernetes service names and, enabling sort of ingress, those sorts of things across clusters. Security. So with Edge, just to kind of speak broadly, right? If you have thousands and thousands of Edge sites, and they all, get a vulnerable application, that's like thousands of points of entry into your application. And just thinking about sort of the geographic disparity of different clusters, it's a security issue. And anytime you read an article about Edge, security will come up. We are not security people, but we absolutely acknowledge that this is absolutely a concern. And so with that was, I guess, sort of like the whirlwind tour of what is Edge, why Edge use cases. Steve is now going to dive into platform stuff and get us to a demo. So Steve.
Thanks, Megan. Hey, everyone. So we haven't really brought up Kubernetes in great detail yet. And there's a table here. There's probably more reasons. This is just at least what I feel is the most relevant ones. As Megan's already described, there's a wide variety of use cases. Edge comes in many different shapes and sizes. Containers, Kubernetes lets us handle all of those cases, or at least that's what we believe. And then something else that I think is really important and something that I think we see a lot at this conference so far is that the adoption is really great for Kubernetes right now, and why not leverage that? We need it to be familiar to developers, to operators, to business people, everyone, right? So I don't think we need to reinvent the wheel. We think Kubernetes is a really good fit. And so here's a really high-level view of how we're thinking about an Edge platform with Kubernetes. We're open to discussion, please. We know everyone has great ideas. I'll say this is an okay enough idea, at least for now. We're still working through it, right? So let me explain what's going on here. So we have the top level, we have that Edge manager. So that's in your public cloud, that's something that's highly available, temperature controlled. That's the brains of the operation, right? So that's running, keeping track of all the other Edge clusters. So I'll just go down to the next tier, those Edge clusters in blue. And so that could be, it could be a restaurant. It could be something running on like a light pole or a cell station. And what we want to do is make those independent Kubernetes clusters. And the reason we feel that's really important is for something Megan actually brought up already, is if you have a network partition. So if I can't get back to my Edge manager, the brain of the operation, at least myself, I'm reasonably independent. I could scale up and I could scale down. I could make some decisions on my own without going back home. And so we feel that's something that's really important with the amount of Edge sites we're going to have, which is on the magnitude of thousands, hundreds of thousands, lots of them. That independence and that autonomy is really important at the Edge. And then lastly, going to the bottom layer here, we have different devices. And the really important part here is just getting to the closest edge. We're going to do all this work, and we have to guarantee that you as your device, as you're in your car, in a train, just walking along, will have the best experience because we're always getting you to the closest site. And so we're going to dive into the Edge manager. So what's up there, and how do we see it? We have 3 components, and this is really motivated by our vision of how we want this to go. So we want it to be this simple. We're not there today, but we want to take an Edge box. You go to your restaurant or wherever it may be, you plug it in, and then from there on out, it's just automated, which means we put an operating system on it that we could lifecycle, we could update, we could manage that. The next part is getting Kubernetes on there and also those core services, right? So this is the second tier. The platform management piece is how do we install Kubernetes? How do we lifecycle it? And then even those things that you just want as part of your platform, it could be Prometheus, monitoring, logging, and those basic services you're going to want in your cluster. And then we have the highest level part, which is actually what we're going to demo today. This is the app manager. And so how do you get your apps, single push of a button, something that's pretty straightforward, out to the set of clusters that you want, and how do you manage those? Again, I think managing a few clusters is really hard. Managing 100 or 1,000 of them is a lot harder. And so we really need to make it really standard and really easy for you to see what's going on and just to get your apps out there and update them. And so actually, this is going to be just a different perspective. So I'm going to get into how we're doing the networking piece for the end devices. And what we've written are core DNS plugins. So we have a central core DNS plugin running up at the Edge manager. And then we have these Edge core DNS plugins running at each Edge site. The high-level view of what they're doing is Edge sites basically just report what they see. What do I see in my cluster? What services are running? I push those up to the central DNS. And then I also ask, hey, what else do you see? And it pushes down the information about my neighbors, right? So there's two use cases that I'm outlining here. So we have that device on the left. So this is the most simple use case. It's just like a standard one cluster, what you would see today in a Kubernetes cluster. I say, hey, I want to talk to Edge app. That DNS says, oh, by the way, I know that's running in my cluster here. Like, here's where it's running. And I just get redirected to the Edge app instance that's running in the cluster that I DNS'd with. And then we have a device on the right, and this is the more interesting use case that takes a little more work. And this is where I DNS with my closest Edge site, and I say, I want to talk to Edge app. That cluster is not running my app right now, but my neighbor is. And maybe it's down the road or wherever it may be. So it has to redirect me to a neighbor, which is its own standalone Kubernetes cluster, and we'll have to pick the one that's like the next closest. And so that's actually, we're going to demo these two exact use cases in just a few moments. And so you could see the two steps on the left here. I actually didn't bring those up. So we're going to do an Anycast DNS, which would get us to the closest cluster, relatively closest cluster, at least by network hop distance. And then the DNS will be able to resolve which Edge app instance or whatever you're asking for is closest. Right now, we're going to be doing like a geographic distance. We understand that's a little broken, but it was just the fastest that we could code up in the time we had. So we're going to dive into Optikon. This is what that Edge app management piece is. And this is, I guess, the novel thing that we built for this presentation. And so you'll see there's not a ton of boxes here, and we really want to leverage what's out in the community. So we've basically wrapped the SIG multi-cluster cluster registry. I know there's been a ton of talks for the SIG multi-cluster, and a lot of other people have leveraged cluster registry. So basically, if you haven't seen it yet, it helps you keep track of individual Kubernetes clusters. You could tag them, put metadata on them, and health and some other things, right? So it's how we're keeping track of our clusters. And then we're also, we wrote basically like a Helm client that can talk to a variety of Helm tillers. I also mentioned the core DNS plugin, so I've already explained that box. And so we have a UI, and we kind of wrapped the cluster registry and Helm with our own API just for some standardization. And then down at the Edge cluster, we want to keep this really lightweight just because those boxes aren't that hefty. So it's basically the Kubernetes core services, Helm tiller, and that core DNS instance that's running with our plugin. And so this is going to be what we're going to have for the demo. Actually, it's all running in VMs on my laptop right now because we didn't trust the internet here. So we've basically offlined everything. And we'll have one VM acting as our central, public cloud, highly available cluster. It's running cluster registry. It's running Optikon. We're going to have 3 Edge sites, Copenhagen 1, 2, and 3. I'm going to end up deploying Prometheus to all of them, and we'll see how easy that is. And I'm also going to deploy a simple web app, like just a static Nginx web server. We're serving like one file. And then I'm going to have 2 separate clients. And we're going to simulate one, which will be my laptop, which is talking to Copenhagen 1. It's going to DNS with Copenhagen 1. And we're going to actually get a response from that instance of the web app. And then I'm going to have another client that's going to DNS with Copenhagen 3. It is not running that web service, Nginx. And it's going to actually redirect me to Copenhagen 2, which would be the next nearest site. All right, I believe this is big enough. We'll come back to this in a second.
Everyone see that okay?
All right, see some thumbs up, so that's a good sign. So this is the UI kind of we've put together here. So we could see that we have 3 clusters. We've given them just string pair labels as you would for nodes. just gives us a way to group them, and we just put them in this little map here. So we have Copenhagen 2, Copenhagen 3, and Copenhagen 1. See, they're healthy. They're each running 8 pods. And so we're using Helm. So basically, just tar up or package up a Helm chart, and we'll attach it here. I'm going to call this prom. You could pick a namespace. We'll put default. And then this part, so our label selectors, I'm actually going to do region Europe, just so that gets to everybody. I could also leave this blank. It would do the same effect since region Europe applies to all 3 clusters in this example. And then you just hit install. So we'll see those pods are coming up. And just to show that this isn't some JavaScript tricks, here are the clusters. So on the left, we have Copenhagen 1. This is Copenhagen 2. And this is Copenhagen 3. And so you'll see that Prometheus is running on all of the clusters here. And so that's a create operation. So let's do an update, actually. So we want to do a canary test, or a new version of Prometheus comes out. This is just basically a label change in the chart. But I don't want to deploy to everyone, so I'm going to say, let's put this to ID 123. And I'm going to hit update. And we'll see that this became version 2. And so there's not really good evidence here, just because of the clusters here. Let me clear this. And I'll do a Helm list. So we'll see now we're at actually revision 2. We're at 6.2.1. So that would be like a confirmation that we actually did our update. If the pods and the containers were different, they would have done what Helm would normally do for an update. So it would have rolled that update for us. Just to make sure my laptop doesn't freak out at me, I'm going to clear this all out. So we'll do region Europe. And we'll hit delete. And again, just for confirmation, we'll see that these will start terminating. And then lastly, I'll be deploying that Nginx web server. We'll call this Nginx. Default's fine. And we'll do kubecon true. You can see I've been practicing this demo, so Safari is already doing it for me. So hit install. Again, just confirm. Right, so we have those 2 Nginx instances running Nginx kubecon on only 2 of the clusters. So cluster 3 actually isn't running it. So here's my laptop. And actually what my laptop is, we're going to see this example right now. So I'm actually going to DNS with Copenhagen 1, and I should get a response from Copenhagen 1. OK, wow, this is very good web development. I'm pretty sure Megan and I are or at least I am, because I did this. So that H1 tag was very hard. And so I'll go to my other client. So this is something that's more interesting. So this is, let me see. This is going to be client number 2. I'm going to actually DNS with Copenhagen 3. And I'm going to get directed, or I should get directed to Copenhagen 2. And the reason is, on the map, Copenhagen 2 is closer to Copenhagen 3. So, in this situation, my client, I'm walking down the street down here, and I want to talk to my great web app here for KubeCon. And it's going to actually redirect me to Copenhagen 2. So I actually have this one in the terminal. And so we'll just run that again. And so we'll see responding from Copenhagen 2. And so that's the example of the demo. And that's those end devices. Hope that makes sense. I'm going to pass it off to Megan to wrap things up.
Cool, good stuff. So, this prototype Edge App Manager that Steve just showcased, this was really just the last couple of weeks of work for us. So there's a whole bunch of stuff that we want to do. First of all, you can access our demo code at github.com/Optikon. The repos are there. You can, set up the UI, deploy our virtual environment that Steve just showed, play around with it. We would love input. There's a whole bunch of stuff that we want to do. Thinking about auto scaling. So imagine that Copenhagen 1 and 2 are both serving the same web application, but for some reason all of the traffic is going to one cluster. How could the other cluster know about the traffic of the other cluster, and they could intelligently load balance? So we would love to get our hands dirty with that. Thinking about edge apps that span multiple clusters. So with Istio.8, there's some really cool multi-cluster stuff coming out. So how could we maybe integrate with that? And work with SIG multi-cluster to help sort of define this space, right? Edge computing is just one of many multi-cluster use cases. So we just want to make sure that what we're not building is like just for edge. Ideally, you could use this Optikon thing, right, for just a couple of clusters. And I think in a talk yesterday, the average number of clusters that people have, if they're doing multi-cluster, is like 5 to 10, right? It's not thousands. So we understand that our use case could be like a little bit extreme. So we just want to make sure that we're building tools that could maybe help other people too. So with that was a lot in a short period of time, and just to kind of wrap things up, so we talked about what's driving edge, touched on a couple of use cases. We think machine learning is one awesome use case. We are not machine learning people, but we are really excited to kind of explore that space. And yeah, just to kind of reinforce, like the reason we were able to build this so fast is because of the hard work that multi-cluster has done on cluster registry, because of the hard work Helm has done to make Helm work really great, and obviously Kubernetes. So going back to Alexis's keynote on Wednesday, just thinking about componentization, right? All of these tools as sort of Legos that you can combine together to make stuff. Like, just kind of reinforce that it is possible, and we're excited to see where we can go with this next. So if this was interesting for you, and Edge is you're intrigued, we do have a BOF that our colleague Matt Caulfield is running at 2:45 today, and we will be there and we can stay after to answer any questions that you may have. So with that, yeah, we've got a little bit of time for questions. I think we only have one mic, so I'll repeat any questions, I guess, through this mic. Anybody? Hi.
So my question is just around the more ethical and business challenges. So as you move computing down to the edge, right? So historically for Prem, I had my own servers and I was paying for that. Then I moved to Google Cloud or whatever cloud solution, I'm paying for that. But as computing moves towards the edge and people start running workloads and all sorts of different edges, how do we figure out who pays for what and have a fair ecosystem and manage that whole process?
Yeah, so the question is, with the disaggregation of the platform and lots of different edge clusters, how do we figure out who pays and maybe think about some ethical considerations? That's on our mind a lot. We work on sort of prototypes in service provider where we think about a pattern where maybe cloud providers and service providers might work together, so that different cloud providers could extend their footprint. Then it's kind of this weird situation where you've got it does sort of get you into this space thinking about things like net neutrality, those sorts of things where if cloud and service provider are sort of partnered together, and an enterprise pays extra money for their service to make it down to the edge. It's on our minds. We haven't gone super far down that road, but it's definitely something that we're thinking about, and we'd love to talk more about that.
Just to follow up, it's a very interesting question. In fact, we have an open source initiative called ONAP, right, which is also a Linux Foundation networking project. It's looking at this sort of problem. Basically, it's a higher order orchestration around service provider lifecycle, design, develop, operate. It's precisely looking at when you're looking at placement in a broader sense, or the moving workloads. What are the business considerations, right? It's much beyond just sort of resource utilization or application metrics, right? It's really around business considerations, looking at those metrics.
Okay, question. So this thing is for something similar. It's probably necessary to make 5G through generation. So obviously,
So let me rephrase. So you're asking about 5G, that's going to happen, and then what was the last part? I missed it.
so 5G is going to happen. The one thing that is known, really well known, is the ready part.
Yeah.
Anyone about the service architecture is that the service architecture needs to be edge, and then as for decals, we get 0 decals.
Yep. And then for those who didn't hear, the TLDR is everyone is agreeing that 5G is going to happen, and when you ask for architecture, you basically get this slide of nothing. And so we have, it's true though, but anyway, actually, so something that we've been doing and was publicly announced at Mobile World Congress was Cisco and Reliance Jio partnering for edge computing. And I guess I'm not certain, I think we're still working through it, and the hope is that we would put a Kubernetes cluster at least some strategically placed cell stations to start. I don't know if all is reasonable or unreasonable, but I think you got to start somewhere, and it's at least that's where we're thinking. And and some things that we're thinking about, and I guess the use case, at least the starting, base case, would just be for serving video. And it could be, we have a really urban example of you have a very densely populated city, and we could cache, video there. Again, it may not be the best edge use case, but it's a starting point at least. And then you also have a more rural example of somewhere where the backhaul is just really expensive. You could think about it like an airplane. So what we could end up doing is maybe these boxes that go into those rural areas just have a lot more storage, and you would be able to deliver HD high quality content as opposed to what you could just do best with the limited backhaul you had. And so I don't know if that answers your question. I think there's a lot of, still a lot to think about, but at least that's where we're thinking about and where we're trying to push to.
What do you imagine the edge will be running on? Mobile phones, cars, what the compute will be running on the edge?
Mm-hmm. Yeah.
Yeah, and so, there's a lot of different options, right? We purposefully kept a lot of these slides a little bit vague because we've thought about lots of different options, right? So this compute could live, anywhere ultimately. Like we've thought about edge compute on a plane, edge compute on a train, edge compute mounted on like a light pole. Smart cities, right? So thinking about smart parking, smart lighting, smart plumbing, some of these less flashy smart use cases. Compute needs to be somewhere. It could be anywhere. Obviously, there are considerations around you need to ruggedize it. It has to be a lot of times this compute will be exposed to the elements, so that does kind of constrain where you can put it. Obviously, if you want kind of a bulkier compute, there are size considerations, so it can't just live anywhere.
I guess the limitation for what we've proposed is it would just have to be enough to run Kubernetes and then, the apps. And it really depends on the use case of how much bigger you get after what it would be required to run a Kubernetes cluster. Yeah.
What about the GPU mining rigs that people have at home? When they're unprofitable?
Yeah, so we have thought about this, and I guess it's more of like a SETI. I don't know who's very familiar with that. Of you could, volunteer your compute cycles to, analyze radio telescope data. But we could almost do the same thing, right? If we had some open source thing that you could just volunteer your computer, we basically will install Kubernetes on it, and then you're just, machine hash number, and that's your identity, and we could put workloads to you. So I think that has a whole another set of questions, concerns, and problems, but I think it could be possible. I don't doubt that. I'm not going to exclude that as something that's unrealistic. I could see that as being very viable. I'm going to go over here. Yep. Mm-hmm. So the question was around DNSing, and will it be more of a mesh than a hierarchy? Mm-hmm. Yeah, so I think, I guess the diagrams, I agree that we've definitely simplified them a lot. And this was our, first shot at how the networking is, and we understand that it's way more complicated than what we've shown. And I do think, we did have Istio that we do want to get service meshes and have something that's a little more intelligent than just, hey, go to our neighbor and hope that is optimal. So I think there's a lot of work to be done with the networking piece. And if you know and have lots of ideas, I would love to talk to you and learn more. And there's a question right here. Yep. Yeah, so the question was about synchronizing state between different edge sites. And so something that was in one of these, but anyway, it's further back. So the way that we're thinking about state is that you will not put state at the edge. The edge will only be used as a cache at best, so it's always ephemeral. So if you're doing something that is stateful, you're always going to maybe do some computation and push the result up to the cloud, so then everyone as long as you're not like in an edge site that has a network partition back up to the central cloud, you should still be able to pick up where you left off, or at least not lose, the cycles that you spent to get that result. So that's how we would see it working. It's kind of, I guess, like MapReduce E, where you're always storing stuff centrally. You're never going to be storing anything at the edge. Does that make sense?
Time for maybe one more question.
Yep.
Yeah, sorry, go ahead.
Have you considered a scenario in which you have a multi-tier application in which one component goes in the edge and the other in the cloud? So,
Yeah.
and in that case, how would the scheduler behave based on the fact that you have limited network
Yeah.
resources?
Yeah, so I guess the question was, thinking about these disaggregated applications that run in both the cloud and at the edge, how would the scheduling work, right? If you have different networking between cloud and edge. Great question. So yeah, we're at the beginning of a long road with this, right? The way that we're thinking about it now is that you basically think of your cloud to edge application as a bunch of different applications. So what this would actually be is like separate Kubernetes deployments that are scheduled separately and can know how to talk to each other, but without one controller deploying both of them, I suppose.
Yeah, so then also when it comes down to, this is very basic scheduling, but you would have node or like cluster labels on things that you would be running in the cloud. So we do think that you would probably end up writing, your cloud version of this app, and then you would probably have some edge version that has some caching functionality and some other things that you would want, and it's probably lighter weight and all the things that we had mentioned. Uh-oh. We made it through the demo, and now locking up here. So anyway, it was just the cluster labels. So I think you would use your cluster labels to put things up at the cloud, and then you could specify some of the other ones at the edge. And I've been thinking about this, and I went to some of the write your own Kubernetes pod scheduler, which was really cool, but also very scary because it seems like you could really mess things up very quickly. So maybe there's optimization there, but it's definitely not like a one-man. It's definitely a big effort. And then I know it's lunchtime, so I think we could let people go to lunch. We'll definitely be here for more questions. We'll be at the BOF later, or just find us now. Thank you.